All right, the next one's a power rule for logs. We've been using this all along, and so this is nothing new. And so if we have log base a of m to the r, we just bring that r down in front, and we have r times log base a of m. Okay, so that's nothing new. We've been doing that for a long time, so that's no surprise. And so we know that that first one's going to be 3 log of 8. Next one's going to be x minus 3 times the ln of 0.27. And our last one's going to be kx times log base 3 of 11. So none of these should be any surprise because we've been doing things like this already for the first few sections. Well, now what if we want to express this into a single log? So this is kind of where sometimes they've got it broken apart. So now we have to think, okay, well, now I need to bring this up here, and then I'll have log of x to the fifth plus log of x to the third. Now, if we want it into a single log, then we have to take x to the fifth times x to the third. And so that's going to give us what? Well, that's going to give us x to the eighth. Now, this one we can do two ways. One way is we can, just subtract them, take the 6 minus the 1/3, and we get a value. Or we can do kind of like what they do here. They're like, okay, well, let's split it into two logs first. And so then we have 6 ln x minus 1/3 ln x. So then we can say, okay, well, now we're just taking basically 6 minus 1/3, and that gives us what? Well, that gives us 17/3 ln x. Now let's go back into the power, and so it's ln of x to the 17/3. Now here we could have just used, the 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 subtracting exponents here. We could have taken 6 minus 1/3 and got 17/3, and so that would be ln of x to the 17/3 right away. And so, it depends on, if you can see that, this piece we're just going to do, the 6 minus 1/3 and get the 17/3, or if you need to go and work it all the way down like that. So again, depending on how each person thinks, it's going to be a different way how they solve these problems. All right, here we're supposed to write the expression as the logarithm of x and y and z. So in this case, it looks like we're going to have a sum and a difference. Okay, so when we do that, the top's going to be, the sum, it's a product, and then we're going to subtract off this one, which is because of the quotient rule. And so we have this, so that's not a problem. Now, what we can do is split those two apart because that's a product. And so then we have x to the seventh plus y to the fifth, and then the z to the half. Remember, square root is a half. Now, here's where I say that a lot of times they want us to bring those powers down. And so when they do that, we just take, bring that down, bring that down, bring that down, and then that would be our solution. That's in terms of logs of x, y, and z, and we bring down the numbers in front, so it's just, a little simpler. We don't have any exponents we have to worry about. All right, so let's stop there and come back for some more.